This is Gautami. So, in our Telegram group, we had shared a PDF for practicing theories of failure. So, today I'll be solving all the questions and I'll be giving you the solutions for all of them in a PDF format in our Telegram group. So, if you haven't joined our Telegram group, the link is in the description. Please join our Telegram group and share the videos to the people who are in need. So let's start with it. So our first question was match the following type of question. So in our first video I had explained you guys that what all things are important in theories of failure. So there I had told to you have to know the shape of the graph for each theory of failure. So this question is based on that. So maximum principal stress theory. So what they do in exam, they give you the different theories, theory of failure, and they'll ask you the different name for it, or they may ask you what type of graph, or they may ask you tau I by sigma y ratios. So in these questions, we have covered this graph questions. So for the first thing, maximum principal strain. Maximum principal stress theory. This has square shaped graph. Maximum principal stress theory, try to recall, we had a square shaped graph and the formula was maximum of sigma 1 comma sigma 2 comma sigma 3 should be less than or equal to sigma u. So this was maximum principal stress theory. So the graph for it is square shaped. Same ways for maximum shear stress theory, which is also called as Tresca theory, the graph is hexagon shape. We had a graph in this way. Yeah. So for maximum octahedral stress theory, this is nothing but von Mises theory. So for von Mises theory, where square terms are involved, the graph is parabolic in nature. Then for maximum principal strain energy theory, the graph is rhombus. So please watch our first video where I have explained about all these things. So we'll go to the second question. So second question, I'll read it for you guys. A small element at a critical section of a component is in biaxial state of stress with the two principal stresses being 360 megapascal and 140 megapascal. The maximum working stress according to distortion energy theory is. Okay. So read the question carefully whenever you come across any questions in any subjects. So in this question they have told it's a biaxial state of stress. So biaxial state of stress in the sense, for example, like if you have a structure, you have a biaxial, you have an axial state of stress, bi in the sense two. So in two directions you have axial stresses. So sigma x, sigma y are present. So using sigma x and sigma y, you can find sigma 1, sigma 2. But in this question, they have already given you two principal stresses being 360 and 140 megapascal. So always write the given content properly and carefully. So sigma 1 is 360 megapascal. Sigma 2 is 140 megapascal. The maximum working stress according to distortion energy theory. So they're asking you according to distortion energy theory, what is the maximum working stress? So you need to find what is the yield stress. So for that you need to know first thing is what is the formula for distortion energy theory. So we know it is sigma 1 square plus sigma 2 square minus sigma 1 sigma 2 less than or equal to sigma y square. So you know sigma 1, you know sigma 2, so find out sigma y. Sigma 1 is 360 megapascal Sigma 2 is 140 megapascal minus 360 into 140 should be less than or equal to sigma y square. When you calculate this, you will get the sigma y as 314.32 megapascal, which can be approximated to 314 megapascal. So answer is option C, 314 megapascal. Okay, we'll go to third question. Okay, third question says, from a tension test, the yield strength of a steel is found to be 200 Newton per mm square. Using a factor of safety of 2 and applying maximum principal stress theory of failure, the permissible stress in the steel shaft subjected to torque will be. Okay, first let us write the given parameters. They have given yield stress, which is 200 Newton per mm square, and a factor of safety 2, and they're telling to use maximum principal stress theory. So it is maximum principal stress theory. So maximum principal stress theory formula, we know it is sigma 1, sigma 2, sigma 3 should be less than or equal to sigma y. And okay, for tension test, since they have mentioned here from a tension test, so for that, like if you have a body which is subjected to tension test, here sigma 1 will be equal to sigma x, or you can take it as sigma. Your sigma 2 and your sigma 3 will be equal to 0. So from here, substitute back to this. So maximum of this is less than or equal to sigma y. So your sigma y is nothing but sigma. And we know factor of safety is nothing but sigma y divided by sigma, which we know sigma y is given in the question, which is 200 Newton per mm square, and we don't know sigma. So factor of safety is given as 2. So from here, your stress will be 200 divided by 2, which is 100 Newton per mm square, or you can write it as 100 megapascal. So the answer for this is 100 Newton per mm square. So the next question is assertion. So from last year, from 2021, they have added MSQ type of questions. So where you can expect this kind of questions. So assertion is a cast iron specimen shall fail due to shear when subjected to a compressive load. Reason: shear strength of cast iron in compression is more than half of its compressive strength. Okay, so you need to think when such questions come. The answer for this is D, because any structure or any specimen which is subjected to compressive load will always fail due to crushing, or maybe due to compressive stresses. It will never fail due to shear stresses. And reason is right. Shear strength of cast iron in compression is more than half of its compressive strength. So the option for this is option D. A is false and R is true. Reason is true. Okay, so the next question. Okay, I think we are done with this question. Yeah, sixth one. Okay. A rod having a cross-sectional area 100 into 10 to the power minus 6 meters square is subjected to a tensile load. Okay. Based on a Tresca failure criteria, if the uniaxial yield stress of the material is 200 megapascal, the failure load is, guys, here they're not asking you any stress, they're asking you load, failure load, and they have given you area. So first note down what and all they have given. Sigma x they have given, it has 200 megapascal, and area is given, that is 100 mm². So from this we can find out principal stresses using the formula sigma 1 comma sigma 1 comma 2 is equals to sigma x plus sigma y divided by 2 plus or minus under root sigma x minus sigma y divided by 2 the whole square plus tau square xy. So you know sigma x 200, sigma y is 0, so divided by 2 plus or minus again 200 by 2 the whole square plus 0. So this will be 100 plus or minus 100. So sigma 1 will be equal to 200 MPa, sigma 2 will be equal to 0 MPa. And here they have mentioned using Tresca failure theory. Using Tresca theory. So Tresca theory, we know maximum shear stress theory, which says sigma 1 minus sigma 2 divided by 2 should be less than or equal to tau y. So here tau, sigma 1 is nothing but 200 minus 0 divided by 2 should be less than or equal to tau y. So from here tau y will be equal to 100 megapascal, and for Tresca theory we know tau y by sigma y ratio is nothing but 0.5. So from this you can calculate sigma y, and sigma y is 200 megapascal. So sigma y is the stress, and in question they are asking to find load. So stress is nothing but force by area. It is nothing but force divided by area. So we want to find out force. So force is equal to shear stress into area. Shear stress we got as 200 megapascal, and area we had 100 mm². So this is nothing but 200 Newton, which can be written as 20 kilo Newton. So answer for this is 20 kilo Newton, option B. Seventh question. Okay, the maximum distortion energy theory of failure is suitable to predict failure of which of the following type of materials. Okay, this I don't think so you guys need my help. Still try to answer these kind of questions. This is very straight directly given questions. It is definitely not composite, it is definitely not plastic, so you need to decide between brittle or ductile, and it is maximum distortion energy theory. So distortion energy theory is nothing but Tresca, and it is well suited for ductile materials. So answer is option B. Okay, so the next question, given that the principal stresses sigma 1 is greater than sigma 2 greater than sigma 3, and sigma E is the elastic limit stress in simple tension, which one of the following must be satisfied such that the elastic failure does not occur in accordance with the maximum principal strain theory? Okay, eighth question tells that which does not occur in accordance with the maximum principal strain theory. So this is a straightforward question. Answer is option B. Write down the formula for your maximum principal strain theory and just analyze the question, what the condition they have given, and you will get the answer for this. So the ninth question is a cold roller steel shaft is designed on the basis of maximum shear stress theory. The principal stress induced at its critical sections are 60 megapascal and minus 60 megapascal respectively. So let's write the given terms. Principal stresses are given. So it is 60 megapascal and sigma 2 is minus 60 megapascal. If the yield stress of the shaft material is 360 megapascal. The factor of safety of the design is what? Okay. And they have told on the basis of maximum shear stress theory. So maximum shear stress theory formula is sigma 1 minus sigma 2 divided by 2 minus sigma 2 minus sigma 3 divided by 2 comma sigma 3 minus sigma 1 divided by 2 should be less than or equal to tau y. Okay, so here we have sigma 1 and sigma 2. So it is 60 minus of minus 60 will become plus 60 comma minus 60 divided by 2 minus 60 divided by 2 should be less than or equal to tau y. So the maximum among all the three is this. So take this term. 60 plus 60 is 120 divided by 60 is 60 divided by tau y. So tau y can be written as so for maximum shear stress theory, tau y by sigma y is given by 0.5. Okay, so tau y, we know sigma y, so tau y can be written as 0.5 into 360. So 60 equals to 0.5. Okay, 1 minute. Okay, so they're asking factor of safety, right? So your factor of safety will be nothing but tau y divided by 60. So tau y now is 0.5 into 360 divided by 60. So it is 180 divided by 60. So it is nothing but 3. So factor of safety of this steel shaft is 3. The last question is a circular solid shaft is subjected to a bending moment of 400 kilonewton meter and a twisting moment of 300 kilonewton meter on the basis of maximum principal stress theory. The direct stress is sigma, and according to the maximum shear stress, according to maximum principal stress theory, the direct stress is sigma, and according to maximum shear stress theory, the shear stress is tau. So they are asking to find the ratio of tau to sigma to tau. Okay, so to find out sigma for both combined torsion and bending moment, there's a formula that is 16 divided by pi d cube into m square plus t square under root. As well, tau is equals to 16 divided by pi d cube into under root m square plus t square. So they are asking sigma to tau ratio. When you take the ratio, this term get cancels out. So sigma by tau is nothing but m square plus t square plus m divided by m square plus t square. So m square plus t square, moment is 400 and torque is given as 300. So when you simplify this and calculate, you will get 900 divided by 500, which is nothing but 9 by 5. So sigma by tau ratio is 9 by 5. So the option for this is option C, 9 by 5. So this is all the 10 assignment question which we had shared in our Telegram group. So we hope it's useful for you guys. So please share it with everyone. Subscribe to our channel for further videos. Thank you.